So today we're going to talk about Lewis structures. And Lewis structures are basically a way to draw atoms bonding. The essential principle that dictates how atoms bond is that each atom in a molecule likes to have 8 electrons around it. So we call this the octet rule. And basically, with covalent bonding, we have a sharing of electrons. So each atom, as long as it has 8 electrons total, can do that through sharing, and it's fine. The other principle we have with Lewis structures is that the central atom is generally the one with the lower electronegativity. So for instance, if I was going to look at, say, the structure of carbon dioxide, carbon dioxide has 1 carbon with 2 oxygens. And so from my electronegativity table, I know that oxygen has an electronegativity of 3.5, whereas carbon has an electronegativity of 2.5. So carbon would likely be the central atom rather than oxygen. So we could start off considering a single bond between carbon and oxygen on both sides, which is a good starting place. You'd also want to calculate how many valence electrons CO2 has. Now, valence electrons are just those electrons that are in the outer shell. And so if it's in group 1, there's 1 electron in the outer shell. If it's in group 2, there's 2 electrons in the outer shell. If it's in group 13, there's 3 electrons, 4 electrons, 5, and so on until 8 electrons in the group 18. So the total valence electrons here would be 4 for carbon, plus there's 6 for each oxygen, and there's 2 oxygens, so it's plus 2 times 6 electrons, which gives us a total of 16 electrons. So the first thing to do when trying to do a Lewis structure is to just draw single bonds first off. And then we must go around and complete the octet. So each bond counts for 2 electrons. And so oxygens can be considered to already have 2, and so it needs a further 6 to complete the 8. And so you draw 6 around it like that. And so now oxygen has its 8 electrons. And we can do the same for here. But as I said, in covalent bonding, the electrons in a bond are shared between neighbouring atoms. So this carbon also considers these 2 electrons to be part of its outer shell. And so it's already got 1, 2, 3, 4 electrons, so it needs a further 4 to have a total of 8. So now we simply add up all of those electrons to see how many we have in this first Lewis structure. We have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So we have 20 electrons. But that's more than the 16 electrons that are available for bonding. So we conclude that this structure is wrong. The way to address this is to simply add an additional bond. And you keep adding bonds until the electrons that are in the Lewis structure are the same as the valence electrons. So by adding 1 extra bond between the carbon and oxygen, I now have this situation for the oxygens, as there's 2, 4 electrons, 6, 8. And so oxygen is satisfied with its 8 electrons. This oxygen remains the same as before. So it has a total of 8 electrons. The carbon now has 2, 4, 6 electrons, so it needs a further 2 to complete its octet. And then we go through again and add up all the electrons and see what we have. which is 2, 4, 6, 8, 10, 12, 14, 16, 18. So it's less than the 20 that we had in here, but it's still not down to the 16 electrons. So we conclude that this structure is again false. And so we repeat the process by adding one extra bond. And now we fill in the remaining electrons such that each atom has 8. If we look at carbon now, carbon doesn't need an additional pair of electrons because it has 2, 4, 6, 8 to complete its octet. And both the oxygens have 8 as well. So then we go through and add the total number of electrons, which is 2, 4, 6, 8, 10, 12, 14, 16. And so that is the correct number of electrons. Those 16 electrons matches the valence electrons. So we know that this must be the structure for CO2. Again, we can go through and do another example. Let's consider nitrogen gas. So normally nitrogen is N2. So if we're going to do a Lewis structure for that, we calculate the number of valence electrons. And so we should see that nitrogen is in the 15th group. So it's got 5 valence electrons. And so N2 would have a total of 10 electrons that are valence. So we repeat the same procedure as for CO2. We draw one single bond and then we complete the octet. So for this nitrogen there's already 2 electrons, and so we need a further 6. For this nitrogen there's already 2, and so we need a further 6. Okay, now the total for the electrons is 2, 4, 6, 8, 10, 12, 14. 14 is greater than the 10 that we need. So we know that this structure must be incorrect. So we simply add another bond and complete the octet. So we have 2, 4, 6, 8. And on this nitrogen we have 2, 4, 6, 8. So each nitrogen has its 8 electrons now. We add the total up, we have 2, 4, 6, 8, 10, 12. This 12 is greater than the 10 electrons that we need. So we add a third bond and complete the octet. So this nitrogen has 2, 4, 6 electrons and needs another 2. And likewise this nitrogen needs another 2 electrons. So now we add up the total, which is 2, 4, 6, 8, 10 electrons. And those 10 electrons agree with the number of valence electrons. So we know that this Lewis structure is indeed the correct one for N2. And that concludes our introductory session for Lewis structures.